The velocity graph of a braking car is shown. Use it to estimate the distance traveled by the car while the brakes are applied. How are you going to figure that out? Well, I'll give you a simpler model so you can figure it out yourself. Let's say I had the same thing. Here's velocity, and here's time. Let's say it was a constant velocity the whole time. From right there, from time equals 0 to time equals something right there. So here's the velocity. How do you figure how far a car has traveled if it has a constant velocity? Yeah, you know this distance equals rate times time, and that turns out in this case to be the area under this curve. This curve in that case is a line. In this case it's a curve, so what are we trying to find in this case? Yeah, you're just trying to estimate this right here. Trying to estimate this. How are we going to estimate that? How many rectangles do you want to make?
6.
6 is a good pick. Why did you pick 6, Biggie?
Because there's 6.
It goes from 0 to 6. So what's the width of the region? 6. It could go from 1 to 7 and we'd still make it 6. So we break it up here, 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 and here. We draw the heights of each of these. Yay, we drew the heights. Now, do you want to make each of those the right hand or the left hand of each height? Do you want to make it the right hand or the left hand of each? Oh, and then there's another break. You could say right here. You did both, and then what did you do after you did both?
Added them together and divided by 2.
Yeah, that's a great way to do it. So you could do this right here. Is this going to be an overestimate or an underestimate? And is this the right hand or the left hand rectangles? These are the left hand rectangles. How can you tell they're left hand?
The point touching the graph is the left.
Is the left corner. Exactly right. So then you just have to visually estimate. Do they give you a function for this?
No.
So you need to visually estimate. So this would be an overestimate. And then what would the right hand look like? Look like this. And then what's the height of the last rectangle for the right hand? 0. It's actually 0 right there. That kind of makes sense, everybody? So the right hand is going to be a underestimate. So what do you do in order to get your great final answer? Add them together and divide by 2. Anybody have an answer to this they'd like to share?
158 feet.
158 feet?
Yeah. So 155.
Yeah. No, another estimate could be 155. If I gave this to you on a test, if I gave this kind of question to you on a test, I'd probably accept as full credit any answer between like 151 and 161, somewhere in there. Because if you just change any of these by a little tiny bit, it's going to change your final estimate. Just how do you do this without actually drawing a graph? Because you don't always have time to draw the graph. Your most valuable asset on the AP exam is going to be time. Time is your most valuable asset. Most points get taken off, not for mistakes, I believe, but because kids they spend too much time on one question and don't spread it out nicely. So in this case, how many gaps do you see? They give you, well, how many data points do they see? They give you 1, 2, 3, 4, 5, 6, 7 data points. They give you a first endpoint and a second. So how many gaps, how many rectangles are there going to be if you were to draw this?
7.
Are there going to be 7?
Probably no.
What do you think? 6, 7, or 8? That's the real question. Okay, so let's draw these points. We have 0, 0. Time is 0.56, so where's 10 right here? Let's make 10 right here. So 6 is going to be right about, I don't know, here. And at 1 second, it's 10.8. And then at 1.5 seconds, it's 15. And then at 2 seconds, it's 18. And at 2.5 seconds, it's 19. And then it's 20.2. So you see those data points? You're going to draw the heights at each of these, right? So those are your divisions. So the question is, do you do left or right? So if you were to connect these points, what would the actual velocity look like? The actual velocity looks like this. So what will left endpoints look like? How many will there be? There'll be a height here. 1, 2, 3, 4, 5, 6 of them. And what will right endpoints look like? 1, 2, 3, 4, 5, 6. So how many regions do you have? You have 6 rectangles. 6 rectangles. in this case, what does the green represent? The right hand or left hand? Equals right. And is it an overestimate or an underestimate? Overestimate. And then the purple represents a what? Left. And is that over or under? Underestimate. So you'd have to use the table. Do they give you the exact values on this, actually? They give you some nice values on this. In terms of what these equations are going to look like, you end up with, so for your left, so it's 1/2 is the width of them. What's the height of the first rectangle on the left? It's 0, then what? 0 is the first height, and then what you add the second half, it's going to be 6.2 plus 10.8 plus 9 plus. Oh, wait, we're doing left-hand endpoints, right? So the height of our last one is what? Is 19.4, right? And then the right-hand ones, where does that start? It's 1/2 times what? 6.2 plus 10.8 plus 14.9 plus 0.1 plus 20.2. There it is. They should be, the difference between the two should be 10.1. Why should the difference between the two be 10.1? It's half of the last one, right? Half of the last one, because this one is greater because this height is 0 right here. You don't lose anything by deleting that 0. Piece by piece, what does this represent right here, do you think? What do you think? The width, exactly, that's really good. Because that stays what changes here? It's 5 plus something, it's 5 plus another thing, it's 5 plus another thing, it's 5 plus another thing. If I is 1, what are you at? 5 plus 2 over n. If I is 2, what are you at? 5 plus 4 over n, correct? So what's going on here? It's going to go all the way to 5 plus what? 5 plus 2 times n over n. Do you agree that that's the last term? I goes from 1 all the way to n. What does this simplify to? What cancels? The n's cancel and you're left with 5 plus 2 is 7. If n is infinitely big, what is this close to right here? So as n gets really, really big, what does that get close to? That goes to 5. What does this go to? 7. Do you agree with that? So whatever curve this is the area under, you're starting at 5 and you're going to 7. Are we okay with that idea? So you're starting at 5 and you're going to 7. So this curve, whatever it is, starts at x equals 5, x equals 7. So we don't know what this curve looks like yet. We'll say this is the x-axis and this is the y-axis right here. Here's y, here's x. This is not to scale, of course. Let's say this is 5, this is 7. This curve does something. We need to figure out what that curve is. We figured out the first thing, which is this is the area under the curve from 5 to 7 of some curve. What's the one piece of information we haven't looked at yet? What's the one piece of information in here that we have not looked at? Back here. So this up here is the height right here. How many different x values are you plugging in? You're plugging in n of them, right? The smallest one is here and the biggest one is here. So what's the function going to be? No, it's starting at 5. The function you are evaluating from 5 to 7. You're evaluating a certain function from 5 to 7. What do you think that function is that you're evaluating from 5 to 7? From 5 to 7. So let's make this from 5 to 7. I'm going to exaggerate this a little. Here's 5, and here is 7. How are we going to figure out the area under that curve? We're going to break it up into rectangles. How many rectangles are we breaking it into? N of them, right? So we break this up into n rectangles. What's the width of each rectangle? The width of each rectangle is 7 minus 5 over n. 7 minus 5 over n. It's the bigger value minus the smaller value divided by n. If you have a piece of wood that's 10 feet wide, you break it into 5 parts, it's 10 divided by 5. How wide is our piece of wood in this case? 2. 7 minus 5 is 2. We want to break it into n pieces, so we divide it by n. So this right here represents the width of each piece. So in this case, see this rectangle right here? That first rectangle? We'll call that one R1 right there. What's the width of that rectangle? 2 over n. And what's the height of that rectangle going to be if it's the right endpoint right there? We did this yesterday. What is the x value right there? 5 plus what? You've moved over once, right? So it's 5 plus 2 over n. So what's the height going to be? 5 plus 2 over n to the 10th. There's the first rectangle. What's the second rectangle going to be? You go up and over like this, and I'll draw, here's that point right there. You've gone over 2 segments. Each segment is 2 over n wide. So what's the x-coordinate right there? 5 plus 2 over n times what? Times 2. That's the x-coordinate at that spot. So what's the height? So what's the region going to be right here? If we call this one R2, what's the width of each one? 2 over n, and it's 5 plus 2 over n times what? To the what power? To the 10th. So you keep on doing that until eventually what do you get to? What number do you get to eventually? 7, because what's 2 times n over n? 2 times n over n. 2 times n over n? 2 times n over n. What does that equal?
1, 2.
Okay, that took 5 answers, okay, to get 2. Yes, 2 times n over n is 2. What's 5 plus 2? So what's the biggest value you're going to get to? You're going to get eventually to 7. What area are you actually finding? You're finding this area right here. That's what you're finding. Yesterday, what value did we start at? We didn't start at 5. What value did we start at yesterday in our examples? 0. Do you have to start at 0? No, you don't have to start at 0. This equals, don't say it out loud yet, but it's the area under what from what to what. That's what you're answering right there. This is the area. This represents the area under what curve from what value to what value. Carter. What is it? Area under what curve? Yeah, it's just x to the 7th from what? 2 to 5. 2 to 5. And the key, there's 2 big clues to make it 2 to 5. If n gets huge, what is 3 over something huge going to be? 0, right? If I goes to n, what's 3n over n? What's 2 plus 3? So it's 2 to 5. This is the summation form of what you were doing yesterday. This is the shorthand version of writing something that is kind of complicated. It's not that bad. So we know the width of the interval is right there. So what's the width of the interval now? Pi over what?
4.
You're so good. So good. It's not pi. It's going to be what? Pi over 4 is the interval. That was really good. So we now know, we think tangent x is going to be involved. And the width of the interval is going to be what? Pi over 4. We don't really want the width. We want to know what's going from and to. We want to know what it's going from and to. So how do we figure out what's going from? So it looks like it's going to go from 0 to what? Pi over 4. And we think it's tangent x. Now, if you think that's true, let's build it and see what happens, okay? Let's build it and see what happens. So what does tangent x look like? This is where all of you stop moving, right? It's an S thing, right? It's an S thing.
It has a lot of asymptotes.
It's a lot of asymptotes, right? Does it go through? What's tangent to 0? 0. So I think it goes like this to begin with, right? Okay, so I'm going to exaggerate it a little bit just so we can have a nicer curve to look at, okay? Is it okay if I do this instead? So we're going from 0 to pi over 4. Okay. So we're going from here. Let's just say pi over 4 is right here. Is that okay? Just say okay. Our first x value, the first one right here, is going to be 0 plus what? Pi over 4n. What's our second one going to be? 0 plus pi over 4n times 2. And our third one's going to be 0 plus pi over 4n times 3. This is the I. You see how it's incrementing 1 every time right there?
But that,
You see that right there?
Not uniform, is it?
Yes, it's uniform. It goes up by 1.
Not in like,
It goes up by 1.
Like generally, it's
Does this match what we're thinking so far? Look at what happens.
yes.
Yeah, it does, because what does this how could you rewrite this right here? What's invisible inside here? This is actually tangent of what? 0 plus over 4n. So this is the area under the curve of tangent x from 0 to what? Pi over 4. Excellent. You have to get good at evaluating these. Actually doing the limits, yes. Evaluate. That's not even a word right there. Evaluate. So let's just do one. Let's make up a simple one. Now, What happens to how complex the limits get if we make it a cubic or a fourth degree or a fifth degree?
It doesn't change, does it?
Well, here's the thing.
Because
Yesterday, do you remember I gave you something that was key to it all? Do you remember this?
Yeah.
I gave you this. Do you remember what it is? N times plus 1 times, and you remember what's underneath? 6. Totally random, right? This was the key to it all. This is the sum of squares right here. You have to memorize this, right? This is going to come up when you're finding the area under the curve of quadratics. What do you think you need to know if you do the area under the curve of a cubic? The sum of cubes. For fourth degree polynomials, you need the sum of fourth. Do these formulas get easier or worse? They get a lot worse real quick, right? So if I ask you to do one of these out by hand, you really hope that it's a quadratic or a cubic. You hope it's a quadratic or a cubic. So let's do a quadratic right now. Is that okay?
Yes.
How about I draw a quadratic? Should it be a nice quadratic or a nasty quadratic? Nice. Oh, I somehow thought you would say that. So let's say I gave you a nice quadratic. Let's make the let's do this. Plus 2, okay? Yeah, let's make it. I just put the dot there. Let's make it a nice quadratic, and I'm exaggerating the shape here. Let's just call this y equals x squared plus 2. Nice, okay? Where do we want to start our integration from? I'm going to say, how about negative 3? And we're going to go all the way to, let's go to 4. So this is what I'd like you to do. This is what we're going to do together. We're going to find the area under the curve from 3 to 4. Negative 3 to 4, thank you. So let's actually set up the summation notation. You're going to write this every time. The limit as n goes to infinity of the sum of I equals 1 to n. You're literally going to write that a few thousand times in your life if you take more math. I hope you do. Now here's the thing. What's the width? What's the length of the domain, Biggie?
7.
It's 7. 7. And how many pieces are you breaking it into? N of them. What's the leftmost x value?
Negative 3.
-3. And what are you adding to that? What's the width again?
7i.
It's 7i over n. Now here's the thing. This is where we have to be very, very, very careful because we added something in here. This right here, hold on. This right here represents the x value, right? But what function are we plugging it into? X squared plus what? X squared plus what? 2. So this right here, I could absolutely give you a question where I give you a picture and I say, write the summation notation. Here it is right here. This is the summation notation. This is really nice. So what we have to do now is evaluate this. We have to evaluate this. In this case, what is x? Well, it's negative 3 plus 7i over n, where n I is 1 to begin with, right? And then what happens? You add another one. I is 2, and then I is 3, and then I is 4, and then I is 5. Does that make sense so far, everybody? That's why it's there. Sometimes you forget this too. So unfortunately, now what do we have to do? We're not substituting anything yet. What do we have to do? What do we have to multiply out? We're going to have to multiply this out. We're going to have to multiply this out. Let me put it this way. It could be a lot worse than this is, okay? Usually I start with something worse and work back to this, but let's just start here, okay? The problem with these is either the example is way too easy or pretty hard. Not way too hard, but pretty hard. This is work, and you have to be able to do this. This is really important. One thing we can do is this. Well, not splitting it into 2. You're just writing it separately. Its limit as n goes to infinity of 7 over n of this sum right here. I equals 1 to n of negative 3 plus 7i over n squared plus 2. It's not that bad. What do we have to do at this point, unfortunately? We have to multiply that. It's not that. Is that okay so far? You guys are my checkers. Does that look pretty good? Is that not bad? Okay, we're good so far. What's the only thing we did there? We took the summation of 3 things and wrote it as 3 summations. That's all we did. That's all we did. Do is we're going to take out the things that stay the same. Remember, we still have this thing floating on the outside. The limit as n goes to infinity, 7 over n times. What does this come out to? You already told me. That's just 11n. Okay, so we'll take your victories, everybody. Minus 42 over n times the summation of I equals 1 to n of I plus what? 49 over n squared times the summation of what? I squared. You have formulas for these two things right here. This represents, this right here, you see this right here? This represents 1 plus 2 plus 3 plus 4 all the way to what? N. This right here, what does this represent? Yeah, 3 squared plus all the way to? You have one of them. What's the blue one equal to? You know what that's equal to. N times 2n plus 1, right? Is that correct? Yeah, it's 2n plus 1 all over 6. Now the easier one, which you actually skipped over, what's 1 plus 2 plus 3 all the way to n? Do you remember what that is? So take a look. So now what can we substitute in for those summations? Those formulas. So what do we have? The limit as n goes to infinity of 7 over n times what? 11n minus 42 over n times what? N times n plus n times n plus 1 all over what? 2 plus what? 49 over times n plus 1 times 2n plus 1 all over 6. Now this looks horrible, but have you guys done limits before? Have you done limits before? Absolutely. Now it's just algebra and limits. How many limits do you actually see right there? 3. I kind of see 3 of them. So let's do it in 3 separate limits. I've broken this up, and I'll show you why this is helpful. Look what happens in the first one. What's 7 over n times 11 over n? This is the limit as n goes to infinity of 77. So what's that equal? It's just 77. Because there's no n in it. Like, what's the limit as 77 stays the same? 77. The larger one is only algebra, kids. It's only algebra. Let's just block it off right there. So what does it turn? What can I cancel first? Let's do this. Let's cancel the... does anything cancel nicely? Not really. It doesn't. So we're going to have to multiply this out. So it's a really good sign that you have a cube here and a cube here. Now here's the thing. There's a shortcut here. You want to see what the small shortcut is? We're only interested in what the coefficients of n cubed are, right? Yeah. Do we care about everything else? No. So this thing is equal to, you ready? This thing is equal to n going to infinity of, what's the coefficient going to be of n cubed? 7 times what? 49 times 2 times n cubed plus something, right? Over what? Do you agree with that? Do we really care what this is? No. Don't care. As long as you recognize that, I'm totally okay with you saying that right there. So what does this become? What does it become? The answer is going to be 7 times 49 times 2 all over 6. Can someone do that on their calculator for me? So we have this. So what is our final answer going to be? 77 minus 147 plus what? 73 over 3. Can someone just tell me what that is on the calculator? It's going to be negative, what is it going to be? Negative 7 plus 343 over 3. What's that come out to be? How does one homework question sound? One homework question sound pretty good? Yeah. So how about you do this? I want the area. So what do we think? Where does the 3 come from right here? Where's that 3 come from? That's just the width. You got that by doing 1 minus negative 2. That's that one right there. That's the width. Nice. Nice. Where's this 1 come from over here? What about this 1? That's just the plus 1 right there, right? And then you have x plus 2 squared. You have x plus 2 squared, right? So you have to be really, really, really careful about this. It's starting at negative 2. What is this? You wrote this properly, Erica. That right there is, what's the starting value? The starting value is negative 2, right? And I will agree that this is what you're incrementing by, right? There's something missing from here. What do you have to do? You have to do what? Plus 2 inside. So this is almost correct. What should it be? It should be, you're right, the limit as n goes to infinity of the sum of I equals 1 to n, bracket, 3 over n is correct. That's correct. That is the width. That's fine. But then what's going to go in here? It's going to go 3i over n. Let's just be really careful about this. Let's write it the full way first. Negative 2 plus 3i over n plus what? Squared plus 1. So did I actually make this a little easier for you? Yeah, I made it a little easier for you because you're going from -2 to 1, and it's x plus 2. So where does this one right here, this 2 right here, where's that 2? Right there. And where's that -2? It is right there. So does this simplify immediately a little bit? It does. It does simplify immediately a little bit. The point is going to be the most accurate in general.
So it's going to be harder to get.
Yes, exactly. The algebra is probably going to be a little harder to get. Exactly. That's a very good thing to point out. So if it doesn't matter and you're going to infinity, choose right endpoints. But if it matters and you have to do it by hand and you have a bunch of time, or the book tells you to do midpoints, what do you have to use?